Thank you for this time. And look, it's a big topic that we'll be spending a little bit of time on today. A very important topic and something that is becoming more and more an issue as we go along for various reasons. A lot of stuff in the media, a lot of stuff being talked about. But today we're going to have a bit of an overview, a bit of a quick whiz through some fantastic resources, because there's a heap of information that's available online. A lot of different industry groups as well as government departments, etc., working in this space. So I've got about 50 something slides, which is far too many for this length of time, so apologies. But it's very much about giving you some links, some signposts, some information to look at further in your particular geographical location, as well as the industries that you're supporting with your involvement with teaching the next generation of farmers and current service providers, etc., in the story. So we'll just get straight into it. I've got a bit of a timeline for you of what we thought we'd cover. See how we go with that. We'll do the best we can. Basically trying to break it up into some components: why climate is changing, the projections of climate change impacts across Australia. And as you can tell from this information, you could probably run a whole week on just about each one of these things. But if you can just get some of the concepts under your brain, some of the terminologies, I've got some really nice audio-visual resources that you'll be seeing as well happen, which is fantastic ways of sometimes explaining complex information in easy sort of chunks, and using audio-visuals and cartoons and a few things, which I think is fantastic, and then it helps to get those messages across. Identifying and assessing the likelihood of climate change impacts. Then I'm going to be running through an assessment framework that I've used with farmers, in particular the dairy industry, but it doesn't really matter what industry you're involved with, to help them to basically do an action planning cycle, if you like, to look at what potentially is coming over the hill, over the horizon, the next 5, 10, 20, 30 years, and to maybe make some decisions now, or to look into the future a little bit for their own businesses and where they want to head. And finally, a bit of time for some questions and discussions. So we'll just keep cracking on after that. First of all, I think we'll just start off at the really basic level, which is greenhouse gas emissions in agriculture. Talked about a lot, carbon dioxide and other sort of chemicals around. It's just basic physics, as one quote's been well put together. It's not rocket science in some ways. It's been known for quite a while that greenhouse gases can have an effect on our climate. Increasing greenhouse gases can trap more heat in the atmosphere, and these things can shift not both Australia but also weather patterns right around the world. So a really nice little video that my colleague Graham Anderson has put together, which gives a really clear and simple explanation. I'll see how we go. Hopefully you'll be able to hear it all right now that we've ticked the button to share sound. This is my colleague Graham Anderson, who is a climate specialist with Agriculture Victoria.
Many people ask, why all the fuss about greenhouse gases and CO2? After all, gases like CO2 aren't necessarily toxic. In fact, plants really like them. Well, the problem is these gases trap heat. The story goes way back to the 1800s, when scientists first discovered the abilities of these heat-trapping gases. We get energy from the sun, which warms the Earth's surface during the day. But at night, this heat then gets radiated back out to space. Now, scientists calculate that if all that heat was lost each night, our Earth would be 33 degrees colder each morning. So they noticed that some invisible force in the atmosphere was trapping the heat. So what was it? In the 1850s, scientist John Tyndall tested these gases from our atmosphere to see which ones were actually trapping heat. First, he removed the trace gases and started with the most common gases, nitrogen and oxygen, which make up almost 98% of our atmosphere. When he applied heat, or infrared radiation, to his surprise, all the heat slipped straight through. He concluded that if our atmosphere was made up of only nitrogen and oxygen gas, then we would freeze every night. So then he tested some of the trace gases, and to his surprise, these trace gases absorbed and trapped the heat radiation, and thus discovered the greenhouse gases: carbon dioxide, methane, nitrous oxide, water vapour. Good work, John.
Thanks, Graham.
So it makes sense. Nitrogen and oxygen are just simple two-atom molecules that don't trap any heat, whereas the greenhouse gases are more complex and have more than two atoms. They have all these extra bits on them to trap the heat. When in balance, these greenhouse gases keep Earth at a stable temperature. But if we add more greenhouse gases, then more heat is trapped in our inner atmosphere and less heat escapes. And scientists are measuring that our outer atmosphere is getting cooler while our inner atmosphere is getting warmer. It's about physics and energy balance. So think of the simple example of two cars parked on a sunny day. Both get the same energy from the sun and their dashboards start to heat up and then start radiating heat. Imagine one car has windows down and the other has the windows up. Which one will be hotter? Both cars are getting the same energy from the sun, but now they have different ratios of energy in and energy out. So basically, adding more greenhouse gases is like slowly winding up the windows and trapping more heat. So that's why scientists expect our warming trends to continue in the coming decades. It's basic physics. This is all about changing the ratio of heat in versus heat out. So that's why we expect to see much more attention paid to how we manage and reduce greenhouse gas emissions, which is good because in agriculture, we don't want things getting much hotter, especially because a warmer world will affect our seasons, weather patterns and variability. So whilst Australian agriculture contributes around 16% of national emissions, our farmers and scientists are doing some great work looking at how we improve fertiliser, grazing and energy efficiency, as well as how we improve the carbon levels stored in our soils and vegetation. And we're seeing more and more supply chains looking at ways that they improve their emissions performance. So we need to get ready. And that's why Australia's carbon farming research, development and extension effort is all about how we improve our knowledge, reduce emissions and support our farmers and industries to get on with the job of growing food and fibre for growing global markets.
Thank you. So yeah, that's a really nice overview of the climate sort of greenhouse gas emissions story from Graham Anderson. Again, you'll see in these, and I've got a PDF for you as well, all the links, hot links are there for you to chase that up yourselves and to get that video or use it as you require it. The next lot of audio-visual information, which I find quite a bit of fun, are the climate dogs. They were put together actually an initiatives from our department a few years ago, and have since not just been for Victoria but Australia-wide. They're a fantastic way of explaining some of the drivers of climate and weather that we experience. And I'll just give you that overview climate dog information for you now. So basically climate dogs are working together to drive the climate. So we need to look at the combined effect of all the indicators to get a good picture of what expect to happen in the future. And as you see these different dogs talking about their different aspects, quite often they actually talk about a lot of this terminology now on the weather forecasts, on the radio and on the television. So there's a sort of a push, if you like, to try and get information out to the general public, as well as using some of these fun ways and entertaining ways of explaining things. So we'll introduce you to the 4 climate dogs now for a couple of minutes. Hopefully this works okay too.
Meet the climate dogs. They represent the climate processes that drive our rainfall variability across Australia. These working dogs love rounding up our rainfall. From a farmer's perspective, when they're behaving, they bring moisture from the oceans and allow it to fall over Australia as rain, hopefully delivering the right amount at the right time. But they don't always work the way we'd like them to, and can sometimes scatter the mob, effectively chasing rainfall away from Australia. These dogs often work as a team, helping one another to bring about our wetter and drier seasons. Over recent decades, some of these dogs have started to change their behaviour, contributing to the variability and changing weather patterns that many farmers have noticed. While we can't control what these climate dogs are up to, there are new and improved tools that can assist farmers to keep an eye on the pack, helping to improve our understanding of seasonal forecasts and manage climate risk.
So that's a really nice way of just starting off the concept about the different drivers of our weather. And you'll go into that website and you can have a look at all the individual dogs have got their own little ways of doing things, but also show a little bit about how that longer term changes are going on in our climate. Now, another one, I've got another audio visual for you, which I found really, really useful, is that explaining this sort of conundrum a little bit in some people's minds about weather versus climate. You often hear the story, oh, well, you know, climate change is supposed to be getting warmer, blah, blah, blah. But we've had this really cold snaps and blah, blah, blah. So, you know, it's obviously rubbish. But this is a really good little video that's come from Neil deGrasse Tyson, who's a well-known international scientist and a whole lot of different areas. I think it's mostly in astrophysics, but he breaks down the differences between weather and climate. So this is another one of those little audio visuals which you might find useful in explaining the concept, which will zap you now.
Predictions about the climate. How come we're so lousy about predicting the weather? Besides, this year we had a colder winter in my town. For all the scientists know, we could be in for global cooling. Here's the difference between weather and climate. Weather is what the atmosphere does in the short term, hour to hour, day to day. Weather is chaotic, which means that even a microscopic disturbance can lead to large-scale changes. That's why those 10-day weather forecasts are useless. A butterfly flaps its wings in Bali, and 6 weeks later, your outdoor wedding in Maine is ruined. Climate is the long-term average of the weather over a number of years. It's shaped by global forces that alter the energy balance in the atmosphere, such as changes in the sun, tilt of the Earth's axis, the amount of sunlight the Earth reflects back to space, and the concentration of greenhouse gases in the air. A change in any of them affects the climate in ways that are broadly predictable. My friend's meandering represents the short-term fluctuations. That's weather. It's almost impossible to predict what will attract his interest next. But not hard to know what the range of his meandering will be, because I'm holding him on a leash. We can't observe climate directly. All we see is the weather. The average weather over the course of years reveals a pattern. I represent that long-term trend, which is climate. Keep your eye on the man, not the dog. Weather is hard to predict, like my friend here, but climate is predictable. Climate has changed many times in the long history of the Earth, but always in response to a global force. The strongest force driving climate change right now is the increasing CO2 from the burning of fossil fuels, which is trapping more heat from the sun. All that additional energy has to go somewhere. Some of it warms the air. Most of it ends up in the oceans. All over the world, the oceans are getting warmer.
So there you go. I love it. Look at the man, not the dog. I love that. He's just such a fantastic scientist, educator and communicator. So this is just another little quick way of trying to explain the differences in that short-term weather versus climate long-term weather patterns that we're talking about. And hopefully that helps to clarify for some people's minds about some of these things of what we're on about. Another way of looking at this longer term sort of trends as well is using things called climate posters, which have been ways of putting together information over quite a long period of time. So I've got a couple for you that have just been updated fairly recently, up to the 2022 data. There's information about rainfall and about temperature. So to give you an idea, this is just a sort of looking at deciles, which are just ways of ranking a whole lot of data, a lot of information with sort of looking at average, the amount of ranking them in lowest on record. For instance, in this case, this is rainfall right to the highest on record, the data, and using colour coding to sort of try and get a good grasp of what that's showing for each year. And as you'll see in a minute, over 10 seconds, we'll see 123 years of data for rainfall right across Australia. So just have that in the back of your mind that where you've got, if you like, a white colour or light colour, that's fairly close to average in terms of the rainfalls for those particular areas. And then you've got the darker blue colour is highest on record for that particular year, and the red colour and the stronger the red at the lowest on record. So just to give you a bit of a zoom phase for this, for the Australian rainfall deciles from 1910 to 2022. So really you're just getting an idea of some of these trends, like Neil deGrasse was talking a bit about that longer sort of trends, not just the year-on-year stuff, or year by year. So we're just starting to see range of different sort of colours. You can get obviously some ones that have been quite low on record and then quite wet on record. So there seems to be a bit of a range of those sort of changes that are going on there. But in particular, if we look at the temperature, I think that really shows. In this case, we're obviously looking at very cooler on record, as well as to the lighter colours for warmer on record, going through over 10 seconds. So you can certainly see on the temperature data that there is quite a trend of getting warmer, if you like, in these last 20 odd years, which is an interesting insights into what we were talking about before with Graham, talking about the implications of the physics happening with the greenhouse gases affecting our temperatures and our weather. Some more information, again, we've got hot links that you can have a look at yourself to get more information to chase that up for your own circumstances where you are. But in Australia's changing climate, some things that are sort of showing up here is a number of days of mean temperatures in the warmest 1% of records. So if you like, very wet, warm conditions, trends are going up around Australia on that one. This is an interesting map about, if you like, fire danger areas or fire danger indicators. Again, over time, since the 1950s, larger and more frequent fires, especially in southern Australia. So certainly is an increase in annual frequency of dangerous fire weather. Another one here about rainfall. We've got some areas that are lowest on record below rainfall type records there. And this is looking for the wet season in particular. We're also getting some highest on records for rainfall. So what that's showing is that this is a very useful sort of little thing to be aware of. As the climate warms, the atmosphere can hold more water than cooler air can. The relationship alone can increase moisture in the atmosphere by 7% per degree of warming, other things being equal. This can cause an increased likelihood of heavy rainfall events, even in parts of Australia where average rainfall is expected to decrease. So if you like, rainfall durations can be, will be probably trending higher or more as we go through as well. Hence, heavy rainfall events becoming more intense. Now here's another little audio visual from climate models from CSIRO, which is another way of trying to explain a little bit about modelling that we're going to be talking about in a minute, about how they go about it. So I'll just zap this one, it doesn't go for that long.
Global climate models, which are based on the laws of physics, enable scientists to answer a range of questions about our climate, like what happens as atmospheric greenhouse gas concentrations rise? Emissions of greenhouse gases, such as carbon dioxide, are a major driver of climate change. This graph shows global warming observed over the 20th century. If only naturally occurring factors, such as variations in the Earth's orbit, solar fluctuations and volcanic eruptions are included, climate model simulations of global temperature cannot match the observations. Add the effect of increases in greenhouse gases to natural factors, and the simulated warming agrees with observations. The extent to which we can restrict future emissions of greenhouse gases is unclear, so scientists explore possible future scenarios by running the models with different levels of carbon dioxide and other greenhouse gases. The output from each simulation provides projected changes for many aspects of climate, such as temperature, rainfall and sea level. Australia is likely to warm in future. Higher emissions cause greater warming. Winter rainfall in southern Australia is likely to decline. Most of the country is likely to experience more extreme daily rainfall. Sea levels are projected to increase at a faster rate than during the last century. Climate projections are being incorporated into the planning processes of governments and business. Climate projections are helping us prepare for a climate that will be different from what we have experienced in the past. Global climate models, which are...
So there you go. So that's another little good explanation. Pardon me, if you're talking to students, etc., about what models are doing, what information they're providing. Pardon me. And here's some more information about some of the data that's been developed from those models. There's a range of different what they call representative concentration pathways, or RCPs, which are basically relating to the concentration of carbon dioxide in the atmosphere, and looking ahead into the future in terms of potentially impacts on temperatures, etc. They also have some other terminology called medium, low, medium, and high emission type levels. And to give you a bit of an idea, this is a good graphical way of suggesting that's being used out of these models for different sort of levels of carbon dioxide, if you like, in the atmosphere over time. What could be what the trends are looking like for the over the years, and the concentrations involved to do with those RCPs. So you'll be seeing some of this terminology in some of the models I'll be talking about in a minute. So just give you a bit of an idea that for the 2.6, there's obviously, if you like, potentially the theory is about trying to sort of reduce the emissions of carbon, of greenhouse gas emissions, and actually sort of having them cut right off by 2010, so you can stabilise the amount of carbon dioxide in the atmosphere. And all these other ones are obviously certain amounts of emissions still going on as we do, as we all talk about in terms of the world, trying to manage those things right across the world as well. So basically you've got medium or high emissions to do with sort of some of those projections going forward. Now, another good way of being able to try and now explain what those climate models that the scientists are doing in terms of impacts of what's going to be happening for this climate variability on our various locations wherever we are in Australia, or in fact around the world. A way of being able to explain that is what they call climate analogues. And it's a simple method for visualising and communicating the impact of these projected changes through the modelling that the CSIRO talk was mentioning about. So what it is, it's identifying an area that experiences similar climatic conditions but separated in space or time for an area that we're wanting to look and see what's going to happen into the future, looking at those various scenarios. So areas where the current climate is similar to the projected future climate of a place. So an example I've got for you now is what's the future climate of Quorn, which is in South Australia. What's it going to be looking like, looking at those different scenarios? Again, there's a link for you to have a look at and to have a play with yourself for wherever you are in your location. It's through the Climate Change in Australia website. Quorn's just basically here. And so what I've just put in is say, yep, Quorn, South Australia, what's the emission scenario? We can have that into some low, medium or high emission scenarios, and the time period, what we want to look at. So basically what this little model's done is said, okay, you've put in some aspects of what you want to look at for that particular location. What's it looking at by 2050? And it's saying, okay, here's the range of potentially changes in temperature that will be happening, rainfall that will be happening, and also analog towns. So similar towns to what we have now is what it will be like in that time. So in this case of Quorn's over there, and it's saying it could be similar rainfall, temperature, etc. to Port Augusta, Broken Hill on this side, as long as other sort of areas as well. So that's a useful way of being able to sort of visualise, if you like, what some of the impacts of climate change may be looking at for some of these models. Another example here is using a similar sort of modelling idea. This time it's in Bendigo in Victoria. And it's saying, okay, what's it looking like if we set these scenarios of this representative climate of 8.5, which is on the higher end of emissions going forward. We're looking into the future. So Bendigo, if you like, will be very similar to Shepparton by 2030, looking at the sort of data that's there. By 2050, it's going to be similar sort of weather, if you like, to Wagga Wagga. And by 2090, it's going to be very similar to Forbes in New South Wales. So again, a really nice way of visualising, if you like, where some of these impacts might be affecting farms in our areas there, which will help to connect up with the next section we'll be doing, which is a little bit about what farmers can be thinking about doing to manage the risk of what some of these models are suggesting might be happening. There's another web-based projection tool. The Climate Services of Agriculture have this as well. You can actually specify a particular location. In the case of what I've got for you here, this is in Dubbo, in New South Wales. So we just click ahead to that. So, okay, so for Dubbo, what we do is we set what we're looking for ourselves in terms of emission levels, time periods, and looking at historical time periods going backwards as well. This is just a bit of information about those two emission scenarios. This is some information that's come from the model looking at, okay, for annual heat risk for Dubbo, New South Wales. So if you like, the historical data was, and they've got definitions of all the heat risk terminology, but 25. But looking at high emissions in the scenarios we've asked for here, that's going to be almost, well, doubling, if not tripling in terms of high emissions for the annual heat risk data. In the frost information with Dubbo, you've got past data of about 38, 39 days. And with this high emission, cutting that right back by virtually half to 14.5 days. Lots of information there that will come out as well in that area. Another good little tool or information that it provides in this, this web-based system is number of years at Dubbo with annual heat risks below 14 days, which is the maximum of greater than more and equal to 35 degrees. So our initial data, if you like, that we've had is 2.3 to 1 in 10 years. And obviously, as we're going through in that modelling, it's going to none annual heat risk below 14 days. So much, much warmer, if you like. And the same way, this is saying the same thing the other way around. Number of years with annual heat risk above 54 days. No, none of those sort of issues, or one perhaps in that early previous data, up to 2.9, 6.3 and nearly 8. So that's a big change in terms of the higher risk days, if you like, on these models are showing. Here's some more information about both annual rainfall plus autumn, winter and spring rainfall. Some ways, look at that, the winter number doesn't change that much in those scenarios, but there's about a third less in the autumn. And there's probably about the same, a third less in the springtime in terms of modelling for the effects of rainfall on these scenarios. And another way of showing that sort of autumn, future autumn rainfall is some of these other little diagrams, which is just suggesting the same sort of trends. So there's different information around, but it's really handy and useful if you want to plug in your own locations and get an idea of what the models are suggesting for that. There's also quite a lot of other information around that have been put together by various other both industry groups as well as governments. There's some projection information there in Victoria, lots of different sorts of ones. This is just an example of a Barwon climate projections in my area in Warrnambool, around our way. There's also climate projections for New South Wales. Again, another link for you there, looking at those sort of locations. And generally speaking, I guess, if you like, overall, there is a general projections experiencing around Australia of national and global temperatures to rise, sea levels rising, marine heat waves, warmer with more heat waves and fewer cool days, fewer tropical cyclones, but greater proportion of high intensity storms. As we remember, we mentioned about the higher the temperature, the more moisture can get held in the atmosphere. Cool season rainfall decline generally, heavier rainfall become more intense, longer fire seasons and more dangerous fire weather. So that's the general projections. Just an example of some numbers in Victoria. We've got some info about global emissions continuing to increase. In the 2050s in Victoria, expecting increases of temperature up 2.5 degrees, number of the days are very hot days, the sea level rising, more intense downpours, declining in cool season rainfall, declining in alpine snowfall, longer fire seasons. So the trends that are in Victoria are similar to the trends that we're showing out for right across Australia as well. So now we've talked a little bit about some of the implications of modelling, etc. I guess the next question is for yourselves to be thinking about working with your students and other industry people, identifying risks to the farming business. And to do that, we look at a risk management cycle approach, which is pretty handy, which is really just trying to identify risks to the business, grouping them into categories, which I'll show you in a minute how we've gone about doing that: climate, people, environmental, essential services and business. Prioritising the risks to the business, analysing those risks and what we can do about them, and then actually putting into practice some strategies, some action plans, and also some trigger points, and then monitoring the risk, or monitoring what we've done in terms of managing the risk to our business, which then feeds back in to our risks identified. So if you like, the overarching aspect of this is very much about the climate impacts, the changing climate impacts that are going to be happening, which we talked about in the previous slide, about warmer weather conditions, about more variable rainfall and generally reduced rainfall, especially in autumns and springs, and fire risks, etc. Those sort of other aspects as well. Really nice way, which I'm sure you've all seen at various times, about managing action planning cycles, etc., to get on top of whatever the issues are you're looking to address. So what we've worked with farmers with in our circumstances is trying to break it up into those 5 categories, just to try and make a very large picture of impacts manageable for farmers to think about. So in this case, the first thing is we're looking at climate risks, which is heat waves, fire events, flood. Failed autumn break is a big one, especially for our dairy farmers in Southwest Vic, but a range of other sort of farmers as well, when we're trying to sort of grow a lot of crops and pastures in autumn, winter and spring, and of course a failed spring as well. We're looking at both identifying what the risks are, and there could be more, of course. Each farm's going to be have their own aspects to think about as well, but also about what sort of risk it is to the business in terms of priority order and what the impact will be, which we'll talk about in a minute. Another area is the people risks on the business, which can be about serious illness or injury. That can also, illnesses, of course, there's a fair bit of things that are going on now, aren't there, in terms of climate variability affecting the sort of bugs that we're getting, both in terms of for people aspects as well as for animals. Look, pressure on relationships, pressure in terms of succession planning, labour management, and a whole range of other sort of aspects, which look, some will be to do with climate, some will be to do with that longer term sort of planning anyway. Pardon me. Rainfall risks or environmental risks, such as the variability of rainfall, soil acidity, erosion, water availability, which is a big one. Irrigation, dams, bores, etc. If you're not getting a lot of rainfall and not a lot of runoff, how are our dams going to be performing over time? And of course, the other big one is biosecurity, whether it's to do with bugs coming in, unfortunately, with foot and mouth, etc., from travellers, but also there are other bugs that might be able to just come on the wing from our northern neighbours as well. So potentially there could be biosecurity incursions coming through as well. Essential services, things like electricity supply for our dairy farmers, milk collection, mains, water, pardon me, all sort of aspects that could be affected down the track in terms of possibly climate effects as well. This is some data about dairy farming business benchmarks. Different businesses will have different benchmarks to be aware of, but again, it's one about just being aware of what the drivers are to profitability in the business and how that might be affected at times in terms of impacts on climate. In particular for our dairy guys, I know homegrown forage is a really important number to try and maximise because it's the lowest cost of feed. So if you do find that your growing season is going to be considerably reduced because of the effects of climate change, that will have an effect both in terms of what you can grow, but also that longer term impact on the ability of the business to manage risk and to produce low cost milk production. When you are also potentially going to be affected with the climate change stuff in terms of milk price fluctuations, etc. as well. So like any sort of rural industries, a lot of it is dealing with uncertainty and managing the risk to the business. Our principle of risk management is the higher the impact and the higher the probability, the greater the emphasis or the need on managing that risk. So either avoiding, adapting, or reducing the chance of that risk having an effect on the business. So a way that I've found quite useful to talk to farmers about is trying to look at a matrix of probability and impact, where you've got a very unlikely scenario of something affecting the business and very little impact. It's a low priority to do anything about it. Where you go right up to the other side of things, where it's a very likely event to happen and the effect on the business will be severe, in which case that's that pink or red colour, and that's really just sort of saying really important to get on top of that sort of issue or these sort of issues in this cordon, have them as a priority. So in the same way, you might say in a particular situation, yep, we've done our little thinking a bit about what the probability and impact is, and we're saying that this particular issue is a medium risk, then we can work on it at that level. So this is the summary of what we've been talking about, using that risk assessment framework to identify climate change risks facing the business. Using that probability matrix, we try and rank that risk of low to high. Then what we try and do is basically put a tick, or if you like, put a information about that level of risk in our big sheet or our framework. And then we rank that in order of what we're going to work on. And then we prioritise the first highest one or two risks for each category, and then try and start thinking a bit about how we're going to actually reduce that impact or reduce the likelihood of it happening to our business. So as an example here, using our probability impacts matrix, we're saying, okay, heat wave risk to the business is moderately impact, but it's going to likely happen. So we're identifying it as a medium risk. We go back to one of these sheets where we've got heat wave conditions. We've ticked the box as medium. We've got other sort of issues that we're thinking is pretty important to be aware of in our business over time. The fire events, potentially flood. Failed autumn break is a high one for our dairy guys, and failed spring's pretty important as well. So they're both medium, high to high. Then we're saying, okay, what is it, the ranking from highest to lowest? The failed autumn break's the most important one of these ones, and the failed spring is the next one, plus those other information there. So this is a good discussion point as well for farmers around the kitchen table, or with advisors, or with their students to be aware of for the business. Put a little comment there, just a starting point, if you like. Spring management, maybe assessing stocking rate in the longer term, maybe locking in grain contracts, whole lot of different ways that we can manage when we're not comfortable, or we're prioritising the potential we might have problems with growing feed, in that autumn, winter period. And finally, developing the action plan, because it's great to talk about all these things, but it's good to actually have a plan of attack as well. So we filled in all those frameworks, those 5 framework sheets that we talked about, breaking down the actions into the timeline and who will do it. So this is part of the action planning information, using SMART goals if we can. Trigger points to inform future management and action. Ongoing monitoring, because it's a living document. It's just something that doesn't get put away forever. It actually has to be looked at on a regular basis. That's our action learning cycle we talked about. So we're continually going around that cycle. And using the risk action plan, because it helps pull together and document for us the knowledge of the farm business and the personal goals of the business, but also as short and long-term risks to the business as well. This way we can develop our plans to manage the impacts of climate change over time. This is an example of a risk action plan. You've probably seen lots of different sort of ways of doing it. There's no right or wrong, but what it is, it gives it nice clarity about the outcome. What are we wanting? Where do we want to go? How are we going to go there in terms of steps? And who's responsible, when, and how we're going to review it as we go through. So a pretty simple sort of logical way of thinking through things. So this is an example of the failed autumn break. So we think that's pretty important. What are we going to do about it? Okay, so our risk action plan is about climate risk, failed autumn break. What's the desired income? We want to reduce the impact of a failed autumn break if it occurs. What needs to be done? Well, in this case, we're going to be monitoring our silage and hay reserves. We will have a target of tonnes in reserve at the end of each month. We're going to also monitor our pasture growth and our soil moisture, monitor seasonal forecasts for the next, say, 3 months. So then we break those up into some steps. For the first one, we'll be producing a feed plan or a budget. Who's going to do that? Well, Tom is, and he's going to start at the end of spring, and he's going to look at it every month. Action plan, step number 2. If we're behind the target tonnes on hand, etc., what are we going to do about that? Well, George is going to have a look at that, perhaps looking at that purchasing feed options, reducing cow numbers, or a combination. He's got a trigger first week in February to start really looking into that information and making decisions on the first of each month. So that hopefully gives you a bit of an idea about some stuff that you can do in terms of what the information is telling us from those climate models for their locations, for our farm businesses, and some ways of farmers actually going about looking at that information for their own business. Now, there's a whole heap of information that's available for different industries as well as different geographical areas. So we haven't had time to go into all that, but certainly here's links for you if you're in New South Wales. Fantastic resources on extensive livestock. Northern Australia climate programs, that's pretty handy as well. You go into that link there, you'll find a whole lot of different sort of information all around here, different industry groups, as well as geographical locations. And some great little pamphlets and handouts here. This one's about grazing management in southwest Queensland. So I found that was really handy to get into that practical tin tacks, if you like, information. There's even information here on climate change impacts in Western Australia. In Tasmania, there is also some information, documents, etc. as well, which is great, well written and really practical. For Agriculture Victoria, there's a whole heap of information that we're well aware of, and I've been involved in putting together some resources, as well as a number of my colleagues have as well, which is fantastic, about information about climate outlooks, about evaluating water supply systems, about ebooks on the Victorian Mallee, which my colleague Heather Field, hi Heather, has been involved with, and also understanding the weather forecast. So that gives you some more information as well in greenhouse gas emissions for farming situations. There's also some really nice information that's around for a range of different sort of areas as well, which I've given you a link for that to have a look at. This is in the Mallee over the coming decades, rainfall restriction, pasture growth. So again, potential climate impacts and resources to help farmers look into those sort of situations as well. So that's fantastic. MLA's also got information on productivity and profitability webinars as well. So we don't all need to reinvent the wheel, but it's just really useful, I think, to be able to signpost you guys to look at where to go for some of this information. And then you can have a look at it yourself. You can pull that information together for your own circumstances, your own students, your own situation geographically, as well as industry connections as well.